Hi, Physics 1, Mr. Janowski here. So this is a question from the Chapter 10 study guide. This is question number 1, and this is another one of those ratio problems. So let's get going with this guy. So first of all, look at the expressions for centripetal force in the footer below. So you don't see the footer, so I've written the expressions that have centripetal force there. And we'll decide which one to use in a little bit. I'll show you how once we know a little bit more about this problem. So if Alice and Billy are driving their cars around 2 different turns, and Alice's car has twice the mass, twice the velocity, and twice the turning radius of Billy's car, how do the centripetal forces each one needs compare? So let's start with, of course, step 1. As soon as I can find out where my cursor is. There it is. So step 1, what are we looking for? We're looking for how do these centripetal forces each one needs compare? So what that means is F sub C Alice over F sub C Billy, so we compare things using a ratio, is equal to question mark, and there are no units. So now we've got to make a list of the things that we know. So we know something about the masses of the cars. So let's see. Mass Alice equals blank mass Billy. So Alice's car is twice the mass. So the number is 2. Does it go on the left or the right? It goes on the right. So whatever the mass of Billy's car is, the mass of Alice's car is 2 times that mass. So that's what that means. Alice's car, also has twice the velocity. So V sub A is equal to something V sub B. Again, the number is 2, and the number goes right here. She's going twice as fast. And twice the turning radius of Billy's car. So radius of Alice is equal to blank. Come on, computer. Blank radius of Billy. The number is 2, and again, the 2 goes here. Yep, that doesn't look like a 2. I can't wait to get a new computer because the Chromebook sucks, and my Mac is starting to suck too. What do you want? It's old. And one more thing to write down. We're going to have to pick the formula to use. So at this point, remember back up here, okay, we have several different expressions for centripetal force. So yeah, this one in general is always true. That's kind of Newton's second law. We also have this one, and we have this one. So which one of these do we want to use? Well, we know the masses, or we know how the masses compare. We know the radii. Do we know the velocity, or do we know the angular velocity? Well, we know the angular velocity, which means we're going to want to use this version of the formula. So not this one. Get rid of that one. So yeah, obviously we want to use a version of the formula that has the thing we need. So that has the thing we need. A version of the formula where we know all the things we need. So VT squared over R. All right. So let's find a nice purple this time. All right. So what do we do here? We go with, back to this idea. That's too dark. It looks almost black. We'll go with it. F sub CA over F sub C B. And as usual, slow computer, hurry up. We write the top thing on the top and the bottom thing on the bottom. So F sub CA is going to be mass of Alice. V, I'm going to leave off the tangential because that's going to get annoying. V of Alice squared over R of Alice. And on the bottom, mass of Billy, V of Billy squared over radius of Billy. So this is all true. Unfortunately, it is very, very ugly because I have an improper fraction. I have a fraction being divided by a fraction. It's really confusing, and it's just a mess. So first thing I'm going to do is fix that. So again, pretty obvious that mass of Alice is where it belongs, and mass of Billy is where it belongs. Perhaps less obvious that velocity of Alice squared is also going to stay on the top, and velocity of Billy squared is going to stay on the bottom. And then we get to the ugly part. 1 of radius of Alice over 1 of radius of Billy is that part. So nothing cancels. I'm going to save all the subbing in and canceling for the end. First, I want to deal with this very ugly fraction. So convince yourself that this idea here is the same thing as this idea here. And then we're going to go one step further. So I'll copy the nice part first. Mass of Alice, velocity of Alice squared. Mass of Billy, velocity of Billy squared. And think, where are the other things going to go? Again, you can do Mrs. Evans' way, or you can just do it the rote way, which is the way the nuns learned me how to do this. So it's the way I'm going to learn you how to do this. Radius of Alice, it's on the bottom of the top. Therefore, it goes on the top of the bottom. RA shows up there. Radius of Billy, it's on the bottom of the bottom, so it must go on the top of the top. Radius of Billy. So however you get there, end up with this idea. So it might look a little bit weird that we have something sub A, something sub A, something sub B, and the flip of that on the bottom, but that is correct. That's how you do this. So let me rewrite this just to make this a little easier to see what's going on. And so this is equal to, just copying down again, okay. And here is the point where we have to go in and decide whether to keep things or replace things. So the first term we get to is mass of Alice. And then look back at what we know over here. Mass of Alice is 2 times mass of Billy. So that's very easy to replace mass of Alice. So I'm going to replace MA with 2MB. Next we get to velocity of Alice squared. Okay, well that's very easy to replace. So velocity of Alice squared is going to become 2 times velocity of Billy squared, and you should be getting nervous because I forgot the parentheses. I did it on purpose. I was just testing you. So yeah, if you're going to replace velocity of Alice with something, and velocity of Alice gets squared, you have to make sure the whole thing you're replacing it with gets squared. So we have that. Next we get to radius of Billy. Well, let's look at what we know about the radiuses. Radius of Billy would be difficult to sub for, so I'm keeping radius of Billy. I'm going to end up switching the other things. So we've got that. Now on the bottom, mass of Billy. Keep it or replace it? Yeah, we're keeping it. Velocity of Billy squared. Yeah, we're keeping it. And radius of Alice, this one we're replacing. This is easy to replace, so we're replacing it with 2 times radius of Billy. So at this point, what cancels? Mass of Billy, that cancels with mass of Billy. Radius of Billy cancels with the radius of Billy. And I've got to do this exponent before I cancel the other things. So make sure you're keeping the 2 that's on the top. So that 2 is there. When I square 2 velocity of Billy squared, when I square 2 velocity of Billy, I'm going to end up with 4 velocity of Billy squared. And on the bottom, what do we have? We have velocity of Billy squared times 2. So does anything cancel here? Yeah, velocity of Billy squared. Yep, that cancels. And 2 over 2 cancels. So if I had done all this stuff correctly, I should end up with this idea. FCA over FCB, can I squeeze this in here? Just barely. Over FCB is equal to 4. So that's one way of writing your answer. The other way of writing your answer, or you can write this as F sub CA is equal to 4 times F sub CB. So if you're looking at this first way of doing it, What you're saying is the ratio of Alice's centripetal force to Billy's centripetal force is 4. So that's true, and that's one way of thinking of it. An equivalent way of thinking of it that some people will find easier to think of is to say that the centripetal force that Alice needs is 4 times the centripetal force that Billy needs. So either way works. So traditionally, when students are doing these ratio problems, they hate them when they first start to learn them, and then some way along the road, they get a little more comfortable with them, and it just all kind of clicks, and it all falls into place, and they say, oh yeah, that's easy. Why did I ever find that difficult? So hopefully you're getting closer to that point. And I'd like this kind of problem. I like giving you this kind of problem because I think you will see this kind of problem when you take any kind of science or math course in college. I consider this a very college-y type of problem. So hopefully you're getting more comfortable with them. If not, rewatch this video, rewatch the other videos where I've done ratio problems, or send me an email or a Google Hangouts request or something like that. So hopefully that helps.